Hi, welcome algebra class again. This is solving equations, and it's going to be a little bit of repeating of stuff you have done in 7th grade, but we chose to start with a tough algebra problem to solve, so I can show you many steps all at once. So you have to do a whole bunch of examples just to get little steps in. Alright, so we have this equation here. It has some decimals in it, has parentheses in it, has more than one term on one side, more than two terms on one side. And we start with distributing. We really want to get, it's kind of like order of operations. In order of operations, it says to do what's inside the parentheses first. In the equation, we kind of want to get rid of the parentheses first. We can't do what's inside, 5 minus 2x you can't do, but you can get rid of them by distributing. So that is our first step. We're going to distribute. Sometimes people call it the rainbow rule. And we're going to rewrite everything that doesn't get used. But this right here, and I'm including the negative with it, this is all going to change. So we have negative 0.4 times 5. And what I do is I hide the decimal for a minute, and I just say 4 times 5 is 20. Excuse me, negative 20, because I have the negative there. And then I add the decimal back in, one in from the right. So it's actually just negative 2, but I have negative 2.0 right now. And then I distribute it to the negative 2x, so I have a negative times a negative. This negative times this negative makes a positive. And 0.4 times 2, again I'm just going to do 4 times 2, which is 8. And I'm going to bring that decimal in as in 0.8. And I include the x. Again, if you're stuck, just do 0.4 times 2 on the calculator just to confirm that you in fact did it correctly. And we continue writing the rest of it. It never got touched. So now we have a new middle chunk to it. And I have these three terms on the left, and two of them have an x. So they're like terms, we call it. So we're going to combine those. And this is the way I show combining like terms. I circle the terms, and I really should have circled the plus sign with that. So I have a giant eraser here. So I'm going to circle all of this 0.8x and the 3x. There, just to make it look better. And sometimes I even write arrows kind of like this. You don't have to do that. Sometimes they look ugly. But if I add a 3x and a 0.8x, that is 3.8x. And I'm going to rewrite the rest of it. So the minus 2, I'm not going to write 0.0 this time. That comes down. And then 5.6. So now I don't have anything I can combine, but I do have some things I can cancel. So I'm going to do the opposite operation to get rid of the things on the side that x is on. So I want that to be by itself. The first thing I have to do is add 2 to the negative 2. That's going to undo that part. But since it's an equation, I have to do the same thing over here. Oops, I shouldn't do it there. I should do it right here. So I line up decimals. Let me get rid of that part. And I have 3.8x equals, and this is pretty easy to add, it's just 7.6. And if I did everything right, it should come out actually quite nicely considering I have yucky decimals. So the last thing to do is to undo the 3.8 being multiplied by x, and I do that by dividing by 3.8. And x equals 2. I always love it when an answer comes out perfect after working with yucky decimals. Alright, we're not done though, because you could have made any number of mistakes. I could have made any number of mistakes without realizing it, and just because it came out to a nice neat 2 doesn't mean I am perfectly right all the time. So I'm going to make sure that I am right. I'm going to check that x equals 2. And that's how I label my check. I don't just write check, I write what I'm checking. And then the next thing I do is rewrite the original problem. If you can read under my green there, 3x minus 0.4 parentheses 5 minus 2x equals 5.6. Alright, so I just rewrite it. Now I basically rewrite it again, except I replace all the x's with 2's. 3 times 2 instead of x. 5 minus 2 times 2 instead of x. There's another parenthesis there. Alright, good. So I just took these x's and put parenthesis 2. So now I can just do some order of operations. This is 6. I want to do what's inside the parentheses over here before I do any of this stuff. So this is really 5 minus 4. I don't want to get ahead of myself. Now I can do what's inside those parentheses, which is a 1. So the check's not as bad as it looked at first, because 1 times anything is itself, so this becomes very easy. It's just 6 minus 0.4 equals 56. Or excuse me, 5.6. I think I keep saying 56. 5.6 equals 5.6. And it worked out nicely. Alright, that takes care of that video. Do me a favor, put some effort into coming up with a question, even if one didn't pop into your head naturally. Go back, look through the problem, and maybe come up with a question, hey, what if? Or just to get your brain thinking a little bit more. It makes your Cornell notes a little more interesting. You have something to ask potentially in class if I call on you. Hey, what did you think about the video? We're going to do a lot of interacting with these videos or these Cornell notes with each other. So it's nice to have some extra stuff written down so you don't have nothing to say. Alright, thank you very much. Make sure you bring in the videos or the Cornell notes next time. Thank you for watching, and we'll see you soon.